2001W. I'm Professor Ayers, and I'd like to introduce some concepts relating to circuits and circuit theory. Circuit theory is important because it's the foundation for a number of engineering disciplines, including computer engineering, computer science and engineering, biomedical engineering, and of course, electrical engineering, which is the largest field of engineering in the world. Now, when we use circuit theory, we're trying to find voltages and currents in circuits, which are models for real physical systems. And there are three underlying assumptions that allow us to use circuit theory, which is relatively simple, compared to full electromagnetic theory, which would be much more complex. The first of these assumptions is the lumped parameter assumption. By this, we mean that the wavelengths for the electrical signals are much larger than the physical size of the system. And if the electrical signals are traveling at the speed of light, c, the wavelength is equal to the speed of light divided by the frequency of the signal. For example, we consider a power system operating at 60 hertz or 60 cycles per second. The wavelength is the speed of light 3 times 10 to the 8 meters per second divided by the frequency 60 cycles per second, or just 60 per second. That gives us 5 million meters, or 5,000 kilometers. That means we can use the lumped parameter assumption at 60 hertz as long as our system is smaller than about 500 kilometers, or New York State. Our second assumption is no net charge on our components. But, as we will see, it's possible to have separation charges within an element of the circuit. The third assumption is no magnetic coupling between elements. Here too, we can have magnetic coupling within an element of our circuit. So those are our assumptions. If they apply, we can go ahead and use circuit theory and avoid the more complex electromagnetic analysis. Now, I'd like to move on and talk about charges, voltages, and currents. Here we'll consider four concepts. First of all, charge, electrical charge, is discrete. In other words, electrical charges are electrons or protons. They have a particular charge. The charge of an electron is minus 1.6 times 10 to the minus 19 coulombs. So the coulomb is the unit of electrical charge. Second, charge is bipolar. This just means that we can have negative or positive charges. Next, the separation of charge results in voltage. If we put negative charge over here and positive charge over here, we will have a potential difference or a voltage between those 2 points. And a definition of voltage is this, dW dQ. In other words, the voltage or potential difference between 2 points is equal to the amount of work dW needed to move an amount of charge dQ from one point to the other. Fourth, the motion of charge results in current. And the definition for current is dQ dt. In other words, the current is the rate at which charge moves across a plane cutting through one of our components or wires in the circuit. So voltage is measured in units of volts, current is measured in units of amperes, and the volt is equal to the unit joule per coulomb, and the ampere is equal to the unit coulomb per second. Alright, and one last thing I'd like to consider is Ohm's law. This tells us the relationship between the voltage and the current for a simple circuit element called the resistor. So, here we will consider a simple voltage source. This could be a battery. We'll show it this way. And it's connected across a resistor, which is a two-terminal element in the circuit with a value R measured in ohms. If the current flowing in the circuit is I, Ohm's law tells us the relationship between the voltage and the current. And we can write it as V equals IR. The voltage is equal to the current times the resistance, where the voltage is in volts, the current is in amperes, and the resistance is in units of ohms. Or, we could also write I equal V over R. For example, if we use a voltage source of 10 volts, and our resistor is 2 k ohms, or 2,000 ohms, the resulting current that flows will be 5 milliamps, or 5 times 10 to the minus 3 amperes. Well, that's it for our introduction to circuit theory. Thank you for your time, and have a good day.